Hey everyone, hope that you're having a great collaborative Tuesday. It's kind of something a little bit different. Let's see if we can find an exciting ink color here. Let's do purple, why not? Alright, so today we're going to learn about some rules about exponents. And you may have seen already on the sideboard, I've got a whole bunch of rules written up there. And what we're going to do is we're going to prove all of them using a very simple idea. All we have to know to prove all of those exponent rules that look super scary on the side is a whole idea of what an exponent is. So remember, we have an exponent like, I don't know, 2 to the third power. Remember that means that it's 2 times 2 times 2. All right, if I have x to the fourth, something like that, that just means x times x times x times x. So this idea of powers is a really nice way to write these things, because if you have like the 17th power or something, you don't want to write it out 17 times. So just by using this idea, which all of you know very well what an exponent means, we're going to be able to prove all of those things, and we're going to be able to do some pretty nifty examples. And these things look so complicated, but once you know the rules, it's really very easy to do these things. So let's start with kind of a simple one here. This is called a same base, because the base of the exponent is that big B. So like in our last couple examples we had here, 2 is the base. That might be the base. I'm going to write that down. And then this guy up here is the exponent. All right, so we use B for base a lot, because base starts with B. All right, so we have two bases here. And we have the same base, we have different exponents. So to illustrate this, we'll get the rule up here in a second. It's already on the sideboard. But in order to illustrate this, let's try it with like 2. So let's do like 2 to the third times 2 to the fourth. Now, on the ACT, they have questions like this all the time. And answer A will always be 4 to the 12th power. And about 90% of America is going to pick A because they think you multiply the 2's and you multiply the 3 and the 4. And then B will maybe be 2 to the 12th power. C would maybe be 4 to the 7th. And then D would maybe be 2 to the 7th. Now, if we think about this for 2 seconds, it's really easy to figure this out, because let's actually write this out. Well, 2 to the third times 2 to the fourth, just think about what this means. 2 to the third, that's 2 times 2 times 2. 2 to the fourth, that's 2 times 2 times 2 times 2. We're multiplying them together. How many 2's do we have all together? 1, 2, 3, 4, 5, 6, 7. So this is just 2 to the 7th power. How cool is that? So we just have the 2's and we just add the 3 and the 4. It's really easy to prove, because all we have to do is say, oh, okay, I have 3 2's, I have 4 2's, altogether I have 7 2's. So it's 2 to the 7th power. So whenever you have any base, b to the m times b to the n is going to be b to the power m plus n. So b to the power m plus n. And that is our first power rule. Very easy to do. So let's take a look at some examples using this power rule. So you want to write that down in your notes for sure, because this is a power rule that comes up all the time. So let's look at some examples here. So this first one, 5 times 5 to the 6th. So 5 is kind of tricky, because you got to remember there's a 1 there. It's 5 to the first power, but you don't even have to really remember that, so I'm going to erase it. Because we have 1 5 here, we have 6 5's here. How many 5's altogether? 7, right? You write this out, it'd be 5 times, and we have 6 5's. 1, 2, 3, 4, 5, 6. If you ever forget exponent rules, just write it out. Write out everything without exponents, and you'll be able to figure it out. So altogether here we have 5 to the 7th power. So we just add the 1 and the 6. Down here we have x squared times x cubed. Give you guys 2 seconds to think about that. We just add these together. This result's going to be x to the 5th power. Okay? Because we have x times x times x times x times x. Altogether 5x's. This one up here, got some numbers mixed in now. The only tricky thing you got to be careful of here is there are no parentheses. So like when we have over here x to the 4th, that is only the x. Think about there being like a giant wall right there. The 2 is not raised to the 4th power. The y is not raised to the 4th power. It is only the x, unless we have parentheses around everything, and we don't. So here we have x to the 4th power, and we have 2y hanging out on the left. Now we're going to multiply all these things together. So let's multiply the numbers first. So we're going to have a 4 out front. So we've taken care of the 2's. So let's just cross them out, because we took care of them. So they're out front here. Now let's look at all the y's. I have how many y's altogether? Well, I have 1 here, I have 3 here, and I have 2 here. So 1 and 3 is 4, 5, 6. So I have y to the 6th power. All I did there was I said, okay, y times y cubed times y squared. I'm going to add all those exponents. I have 2 here, I have 3 here, I have 1 here. Altogether, I have 6 y's. So I took care of all the y's. And now let's see what I have for the x's. Well, I have 4 here, and 4 make 8, and 4 make 12. So I have x to the 12th power. So this is what they mean when they say simplify. They want us to write it in the simplest terms possible. So they want us to kind of condense it. They want us to make it smaller. And we do that by mixing together all of the variables that we can. Why don't you try number 7 on your own? Do it just like I did the last one. Multiply the numbers and then see how many of the u's and how many of the v's you have. So you can pause the video if you need to and just give this a quick shot. All right, let's see if we get the same thing. So I'm going to start with the 3 and the 4. 3 times 4 is 12. Now look at the u's. I have 3 here, and I have 4 here. Altogether, I have u to the 7th. And let's look at the v's. I have 4 here, I have 2 here. That's v to the 6th power, because 4 plus 2 is 6. And that is all there is to this, guys. So multiplying two exponents together that have the same base, I'm just going to add those exponents straight across, and that's it. Now let's learn a new rule. Next one is b to the n to the m. So I'm taking this b to the n and raising it to the m power. So an example of that, we used 2 last time. Let's do 5 this time. Let's do 5 squared to the 4th. So order of operations is a little bit tricky here, because what this is saying is I want 5 squared to the 4th. So this means I can write this out, 5 squared times 5 squared times 5 squared times 5 squared. Right? I've got 5 squared to the 4th. I'm multiplying it together 4 times by itself. Now we can use our last rule. How many 5s altogether? 2, 4, 6, 8. So this is 5 to the 8th power, because I added the 2 plus 2 plus 2 plus 2. So it gives me 5 to the 8th. Well, how the heck can I get 8 from 2 and 4? I can multiply them. Let's try it with another one and see if it works. Let's do 3 to the 4th squared. So that's going to be 3 to the 4th multiplied by itself, because it's squared. So that's 3 to the 4th times 3 to the 4th, which is, add those together, 3 to the 8th. So it works. We just multiply those two powers, and that's it. So b to the n to the mth power, that means that I have b to the n m times in a row. And when we can just add those, so that's b to the n times m. I think on the board I might have mn, but either way you do it, it doesn't really matter. So that is our second rule. Definitely want to write that one down in your notes too. It comes up all the time. So let's try this one with a couple examples. 5 squared to the 3rd. So we just said, we just multiply these two together. So it's 5 to the 6th. Notice that's very different from 5 squared times 5 to the 3rd. All right, that was our same base one we had at the beginning. In that case, we would add them, but that's not what we're doing. We're taking, this is called a power to a power. So a power to a power, and we multiply them together. This one down here, x to the 8th to the 4th. Think about that for a couple seconds. So hopefully you got this is x to the 32nd power. You can think about that. It's x to the 8th, x to the 8th, x to the 8th, x to the 8th. I have 4 of them. 8 plus 8 plus 8 plus 8 is 32, excuse me. Now over here, this one looks a little bit different, but it's still pretty simple. We just multiply them all together, because 2 times 3 is 6, so we have y to the 6th to the 4th. 6 times 4 is 24, so we have y to the 24th power. That's all there is to it. All right, let's try the next one. AB to the n. So this is called a product to a power. And let's try it with something. Let's try it with, like, I don't know, let's do 3x. 3x. Let's do it to the 4th. Let's see what happens. So this means I want to take 3x to the 4th power. So I want to do 3x by itself 4 times. So 3x times 3x times 3x times 3x. So let's look at the numbers first. 1, 2, 3, 4. So I have 3 to the 4th times 1, 2, 3, 4 x's times x to the 4th. Hey, cool. Looks like it just goes to the x and it goes to the 3. And that is exactly what happens. So ab to the n is just a to the n times b to the n. Now I see big mistakes with this. Usually people forget to put an exponent to a number, which is kind of ironic because usually the variables are what make algebra hard, but in this case every time people forget to do the number to the power. So if we have like I don't know, wz to the 5th. People have no issue knowing that's w to the 5th times z to the 5th. But when you have, like, I don't know, 7y, let's say, squared, so often people will write just 7y squared. But what are they forgetting to do there? That's wrong. What are they forgetting to do? They're forgetting to put it to the y and to the 7. So it's 7 squared, which is 49y squared. So you just have to remember to distribute it to both of them. Okay, so that's our third rule, product to a power. So make sure you write that down in your notebook. All right, a couple more examples. xy cubed. Well, I just distribute it to both of them. So that's going to give me x cubed, y cubed. This next one, I think we might have done. No, it was similar, but not quite the same. So 3x squared, it's got to go to the x, and it's got to go to the 3. 3 squared is 9x squared. That's it, we're done. Over here, now this one we have 3 different things, but it still works the same way. We could try, you could actually write it out. It's 4x squared y, 4x squared y, 4x squared y. Because it's cubed, right? 4x squared y, 4x squared y, 4x squared y. But we can also just distribute it to everybody. So 4 to the 3rd times x squared to the 3rd. Ooh, looks like we might get to use a power of a power. Times y cubed. So we have 4 cubed, x squared cubed, and y cubed. Well, 4 cubed, that's just 64. Now, x squared cubed, what do I do with these guys? This is the last rule we learned. We're going to multiply them. So that's x to the 6th, and then y cubed. And that's the most simplified we can make it. Cool. So that was a little bit tricky because we had the x squared cubed, but we just combined 2 of our rules. All right, b to the 0. This is one of my favorite things in math, actually. So b to the 0, let's talk about what happens here. Let's think about the number 2 to the 0. And to really understand something to the 0 power, we have to make this pretty cool chart that we're actually going to use on Monday as well. So you have that to look forward to. But let's make a chart of, let's just list off n, and let's list off 2 to the nth power. So usually this is pretty easy to start if I start with 2. So we think about this is going to be 2 squared. 2 squared, which is 4. Let's think about 3. That's 2 to the 3rd. So I'm just listing off n values here and saying what happens when I take 2 to that power. So 2 cubed, that's 2 times 2 times 2, which is 8. And if we keep going up, 4, so we have 2 to the 4th. 2 to the 4th is going to be 2 times 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16. We can keep going with this. 2 to the 5th is 32. 2 to the 6th is 64. And that continues on. So what you notice here is as you go up the ladder, every time we're multiplying by 2, which makes sense because we're adding one more power of 2. So we multiply by 2 as we're going up the ladder there, from 4 to 8 to 16 to 32 to 64. But what's more interesting is what happens as we're going down the ladder. Check it out. How do I get from 64 to 32? Well, I divide by 2. From 32 to 16, I divide by 2. 16 to 8, divide by 2. 8 to 4, I divide by 2. So, if we keep this up, so 2, 3, 4, 5, 6, we can go down. 6, 5, 4, 3, 2, 1. So 2 to the 1st power. Well, if we continue our pattern, we should just divide by 2. 4 divided by 2 is 2. Which is why 2 to the 1st power is 2. But where it really gets interesting is if we go up one more step on our ladder. What if we divide by 2? Well, what's 2 divided by 2? It's 1. So 2 to the 0 power is 1. Isn't that cool? A lot of people ask me, why the heck is 2 to the 0 1? And this is why. Because this pattern cannot be broken. You have to go up by multiplying by 2. You have to go down by dividing by 2. This works for every single power. Check it out. If I do it for 3, so I'm doing 3 to the n this time. 3 squared is 9, 3 to the 3rd is 27, 3 to the 4th is 81. So I'm multiplying by 3 as I go down. If I go up the ladder, though, I'm dividing by 3, dividing by 3, divide by 3 again. So 3 to the 1st is 3, and then divide by 3 one more time. 3 to the 0 power is 1. Every time you get this 1 on the ladder, which is kind of cool. So b to the 0, no matter what b is, 1. Okay? That's kind of cool. So make sure you write that one down. So let's try some. 4 to the 0, 1. 2xy to the 0, 1. Seeing a theme? How about pi to the 0? What do you think? It's 1. 2 to the 4th times 2 to the 8th, all to the 0, 1. How about this guy? Big, messy, yucky fraction to the 0, 1. Everything to the 0. Anytime you have a 0 power on the outside, it's equal to 1. Tempting to say it's equal to 0, but it's not, because that doesn't work in our ladder. Right? We have to have that 1 at the top. We can't have any other number there. That's kind of cool. So, a couple examples for solving for x. Because you might see some of these in the homework. I don't recall if they're in the homework, but I think they're on the quiz, so that's why I want to do these. So here we have 2 to the x times 2 cubed. Well, we know that when we have the same base here, this was the first rule we talked about. What do we do with the exponents? We add them together. So it's going to be 2 to the x plus 3 is equal to 2 to the 12th. So a little thing about exponents is if we have the same base, those exponents have got to be the same. So this creates an equation for us. X plus 3 equals 12. Just subtract 3 from each side, and we have x equals 9. Kind of cool. So if x is 9, we'll end up with 9 plus 3, which is 12, which works out. The next up, we have a power to a power. So we know if we have a power to a power, we multiply those. So we have this time 7 to the 5x is equal to 7 to the 45th. So we have 5x has got to be the same as 45. 5x equals 45. This time we have multiplication here, so we're going to divide. And we end up with x equals 9. Kind of cool. All right, so your homework for tonight, what I want you to do is the yellow worksheet, just numbers 1 through 16. All right, tomorrow we're going to be going over some problems that are a little bit more in depth. We'll be looking at the rest of the worksheet, so we're going to be doing some stuff with fractions, which is a little bit more complicated, but nothing you guys can't handle. Now, if you have any questions, please email me. I'll be checking my email, and feel free to email me and give me whatever you have. Or even if you just want to say hi, that's just fine. I'll at least know that you watched this video to the end. So good luck on the worksheet. Be nice to the sub. And I love you guys. That's why I'm here. Have a great day. Have a good one, guys.